So if you want to try out the Nutkicker motion controller, then what you're going to want to do is go to github.com/dirty/Nutkicker motion controller, and this is the address. I'm going to put it in the description, and then click on clone or download and download zip. Yes, you want to save it somewhere on your computer, and then go to your downloads folder, right click and extract all, and just extract it to somewhere on your hard drive. So when that's done, you can go inside this folder structure and click on Nutkicker motion control software. This is the entire Unity project, but you're only interested in builds and then NMC development build, and you can execute the Nutkicker motion control software. So when you double click on here, there you might get, oh yeah, this is a warning like, oh, caution, pretty dangerous, but you can execute anyways. Trust me, I'm way too dumb to be programming any viruses into this. And once you have it running, then this is the window you're getting. So once we are inside the Nutkicker motion control software, what you can do is you start SimConnect, and probably also the rig view, vehicle view, force view. That makes sense. Platform control. Yeah, I guess that's all you need. So what you want to start with is start server. That means now the server is listening and waiting for a simulator to connect. So I'm going to start DCS now. It's going to take a few seconds until you see it. There is DCS, and we can start the simulator simply by starting the mission. So I'm going to use the F5 free flight. That's it. Once the simulator is patched with the export.lua file, then everything will start automatically once you start the simulator. You can see it here. It's listening, and the sim is starting. And as soon as you are somewhere around maybe 50%, now you can see client connected. That means the simulator is connected. And as soon as you hit fly and start the mission, that's when the motion data is flowing. Now you can't see it here. Maybe I can show you like this. The motion data is flowing already, so you can see that the vehicle is reacting. So whatever you do is going to be represented by that little vehicle view in the Nutkicker motion control software. Now, in order to get the platform down there moving, what we first have to do is go to platform control. Right now the platform is parked. You can see it here, it's parked. So you want to go from park to pause. That's when the platform starts moving and goes to the pause position. Now it's in transit, now it's paused. Now it's actually safe to sit on the platform. You should buckle up, because when you go from pause to motion, that's when the platform will actually execute the motion. Now the motion is active, and it's going to be faded in over like 5 seconds. So it's it starts very gently, and over a time period of 5 seconds, it will display the motion coming from the motion queuing algorithm. You can fly around, see if the motion of the platform does what you expect it to do. You can tune the motion. I'm going to show you that in another video, but for now it's just a demonstrator to be just looking at it and see if the motion somewhat matches what you expect. So if you want to pause the platform, then the opposite, you basically think of this as like a clock. You start here, then you go from pause to motion. Then once you're done, you go from motion to pause. And you can see the platform will go back to the neutral position. If I give some control inputs, it won't execute it. They will fade out. Now it's paused, and you continue from 1, 2, 3, 4. Here the next step is pause to park, and the platform will go down to the parking position. So what you see here is the force view. So these are the forces acting on the vehicle. So take a look at it. If I fly around and I pull some G, then you see the G load increasing. And if I add in some rudder, you can see here the lateral acceleration. This is the vertical acceleration, and this is the longitudinal acceleration. So some rudder input will give you a lateral force on the aircraft. It's not that much. It's they are to scale. So when I pull like 8 or 9 G, you can see this long diagram, this bar graph going up. But the lateral forces are very small, and that's very realistic. That's about as much as you can get in a small jet like this. And there's also longitudinal acceleration. Like if I pull the power back to idle, you see that there's a strong deceleration here. And if I bring the power back forward, then you can see that that deceleration turns into an acceleration. And there's something else that becomes apparent when you represent these forces in this way. Whenever you pull G's, there's an angle of attack on the aircraft. So every every time you pull some G's, you will basically, as a parasite effect, you will generate a longitudinal acceleration. That is just the fact that the lift does no longer act perpendicular to the longitudinal axis of the aircraft. So look at this. If I pull some G, there will automatically be a little bit of longitudinal acceleration. It's not that much. Here you can see it. And if I let go of it, it'll shrink back down. So again, you see with every increase in G load, because there is an alpha that's required for this, the angle of attack is required, then that will generate a longitudinal acceleration. And it is also represented in the platform. Like if you look here, when I pull G's, this thing will make a little jolt forward. And initially I thought, this looks strange, but that's actually the way it's supposed to be, and it corresponds to the longitudinal acceleration that you can see in the force view. So pulling some G, and you can see this very little jolt forward. It might not be very apparent, but if I look at the data, I can actually see it makes a little jolt forward. You can see the platform jolts forward slightly. So that's it for this video. Maybe we're going to make another one with the couple of other features, but if you just want to try it out and play around with it, then that's what you should do. There are some other features like motion tuning. I'm going to explain that, and offsets and rig config. That's to set the parameters of your rig and the tuning, the values of your motion, but that's for another video. So if you want to play around with it, play around with it. If you want to contribute, actually, yeah, I'd be totally happy to support anyone who wants to learn to code or to contribute in any way. So thanks a lot for your attention, and have fun playing around with it.